Dots in Unity. Should you use it? Hello and welcome to episode number 5 of the Unity Performance Task Force. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick off with a question for you. Have you ever wondered why adding more CPU cores to your gaming rig doesn't magically double your frame rate? Or why that beautifully architected game you're building starts choking when you spawn a few hundred enemies, even though your CPU usage sits at 30%? Sounds familiar? If so, this episode is for you. Today we're tackling DOTS, the data-oriented technology stack. This is one of the most requested topics I get, and I held off covering it until now for a reason. DOTS isn't just a new API you bolt onto your existing code. It's a fundamental shift in how you think about game architecture. And yes, it can give you massive performance wins, but it can also turn your production schedule into a dumpster fire if you're not careful. So let me be upfront. I am not a DOTS evangelist. I'm not here to sell you on the future. I've used DOTS in several production projects. Some went great, others taught me expensive lessons. Today I'm going to give you the unfiltered version, what DOTS solves, how it works at a high level, and most importantly, when you should absolutely avoid it. Let's start with the why. Why does DOTS even exist? Here's the uncomfortable truth about game development. Our memory access patterns are terrible. In a typical frame, your CPU needs data from a player script over here, then weather system data over there, then AI state from somewhere else entirely. Thousands, sometimes millions of random memory accesses per frame. Now, you might think the CPU just grabs that data and keeps humming along. But that's not what happens. What actually happens is the CPU sits there waiting. Because the memory controller is off fetching data from RAM, which compared to the CPU moves at geological speeds. Even modern CPUs, with all their clever tricks, out of order execution, speculative fetching, all of it, they still spend most of their time waiting on memory. And the more randomly you access memory, the worse it gets. Let me give you a real-world analogy. Imagine you're at home in your pajamas. You decide you need bread, so you get dressed, walk 10 minutes to the bakery, buy the bread, walk home, and put your pajamas back on. Then you realize you need fruit. So you get dressed again, walk to the fruit shop, buy fruit, walk home, pajamas back on. Oh wait, you also need vegetables. Dressed again, vegetable shop, home again, pajamas. After an hour of this insanity, all you've accomplished is gathering 3 items. That's your CPU on a typical game frame, constantly context switching between distant memory locations, getting dressed and undressed, so to speak, over and over. Now imagine instead you made a shopping list, put it in one place, got dressed once, and bought everything in a single trip. Wouldn't that be more efficient? Of course it would. That's DOTS. That's the entire philosophy in one analogy. DOTS organizes your game around data, not objects. Data is king. And Unity takes responsibility for laying out that data in memory efficiently and scheduling your code to process it in big, contiguous batches. So how does it actually work? DOTS is built on something called ECS, Entity Component System. 3 concepts. First, entities. An entity is just an actor, a player, an enemy, a particle, even a shopping list. It's an ID really, a label that says this thing exists. Second, components. Components are pure data, no code, just data. So an entity representing a bottle might have a color component set to black. An entity representing a character might have a locomotion component holding walk speed, run speed, jump speed. Third, systems. Systems are pure code. They run on entities that have specific components. So a movement system might say, find all entities with a locomotion component and a position component, and move them based on their speeds. Notice what we've done. We've split code and data. Traditional MonoBehaviors mash them together. Dots pulls them apart. And that separation lets Unity do something magical. It can pack all the locomotion components for 1,000 entities into a tight contiguous block of memory. Then it can schedule your movement system to tear through that block in one pass. No random jumps, no cache thrashing, just pure linear processing. And because the data is contiguous and the processing is predictable, Unity can run your systems across multiple CPU cores in parallel, automatically. You don't write threading code, you don't manage locks, Unity handles it. That's the promise. Let's make it practical. Here's the mental model. In a traditional MonoBehaviour world, you might have a waypoint patrol script. It holds a list of transforms, a navmesh agent, and some logic to move between waypoints. Code and data bundled together. One script per ghost. In Dots, you'd split that into 3 pieces. First, a waypoint component. That's just data. A buffer of positions. Second, a movement target component. That's data too. An integer saying which waypoint you're heading toward. Third, a patrol system. That's code. It finds all entities with waypoint and movement target components, calculates distances, updates positions, and moves them. Now when you have 100 ghosts, all their waypoint data sits together in memory, and your patrol system processes all of them in one tight loop, possibly across multiple cores. The wins show up in the profiler. In the manual for homomorphic position, you'd see 100 separate update calls scattered across the main thread. In the Dots version, you see one system scheduled in parallel, running on worker threads, finishing faster. So that's the upside. What about the downside? Here's what nobody tells you in the Dots tutorials. Dots is not production ready. Not in the sense that most developers mean production ready. Yes, Unity ships it. Yes, you can use it. But it changes constantly. A package update can break your build. A Unity version upgrade can change behavior in subtle ways that only show up in bug reports from players. And here's the bigger problem. If Unity doesn't provide a Dots native version of a feature you need, you're on your own. Navmesh agents, there's no drop-in Dots equivalent. Animation, you're writing a lot of low-level code. UI, good luck. Physics, it exists, but the API is nothing like what you're used to. So when should you use Dots? Use it when you have thousands of homogeneous entities doing similar processing. Think bullet hell shooters, strategy games with thousands of units, simulation games. Any scenario where you're bottlenecked by processing lots of similar things. In those cases, the wins are real. We're talking 10x, 20x speedups. The kind of gains that let you ship on lower-end hardware or crank up your entity counts. But use it only if your team has time to learn it, your project timeline has buffer, and the features you need are already Dots native, or you're willing to build them yourself. When should you avoid Dots? Avoid it if you're on a tight production schedule and your team is new to it. Avoid it if you need features Unity hasn't ported yet. Avoid it if your game doesn't have the kind of massive scale homogeneous processing that benefits from it. Traditional MonoBehaviour code is slower, yes, but it's stable, well documented, and every plugin you need already works with it. Sometimes good enough is better than optimal but risky. Here's my rule of thumb. If you're building a 1,000 zombie wave shooter and your profiler shows CPU bottlenecks in enemy AI, Dots is worth exploring. If you're building a narrative adventure game with 20 unique characters, dots is overkill and probably a liability. Let me give you the action plan. If you want to experiment with dots, here's what you do. First, pick a small isolated system in your game. Something like particle management, simple enemy AI, or procedural decoration. Not your core gameplay loop. Not anything tied to a dozen other systems. Second, check the dots documentation for your Unity version. The packages change constantly. Make sure the version you're using is compatible with your project. Install 3 packages: Entities, Hybrid Renderer, and the Dots Editor. Third, prototype the conversion. Take your MonoBehaviour script, split it into components and systems, and measure the difference in the profiler. Don't trust your intuition, trust the numbers. Fourth, if the wins are real and the workflow is manageable, expand carefully. Convert one system at a time. Keep the rest of your game in MonoBehaviour land. Hybrid workflows are supported. You don't have to go all in. Fifth, set a hard deadline. If you're not seeing clear wins within 2 weeks of focused effort, roll back. Dots is powerful, but it's not magic. If it doesn't fit your project, that's fine. Let's recap the 3 big ideas. 1. Dots reorganizes your game around data, not objects. It packs similar data together in memory, which eliminates cache thrashing and unlocks parallel processing. 2. The ECS framework splits your game into entities, which are IDs, components, which are pure data, and systems, which are pure code that acts on entities with specific components. 3. Dots delivers massive wins when you have thousands of homogeneous entities, but it's not production stable in the traditional sense, and it requires a real investment to learn and maintain. If you want a second pair of eyes on your project, we do focused performance audits and training sprints. We can help you figure out if dots make sense for your specific case, or if there are simpler wins you should chase first. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.